Cross-site scripting attack. What is this kind of security issue? What kind of attack is cross-site scripting? What is the underlying mechanics of this attack? How serious it might be? What are the different types of cross-site scripting attacks? And most importantly, how to prevent this attack to happen on your application. My name is Bartosz and I'm going to answer all of those questions in this video, so make sure to stick around. Angular Academy. First of all, a small exercise to see what can actually happen if you can execute some let's say unintended code on your website. So just stop for a second and look for the link in the description so that you can see how you can make your website do Harlem Shake. It's going to be funny. Once you do this, let's go further and understand four different attacks, four different types of cross-site scripting. Over the internet, you can find content or articles which claim that there are three kinds of attacks, which is stored, reflected, or DOM-based attacks. But basically, DOM-based attack is a variant of both reflected or stored cross-site scripting. What does this really mean? First of all, cross-site scripting can be executed on the server side when the server is rendering the template on the server side and injecting some malicious script because of the vulnerability on the website that is then sent to the browser, and there's already automatically JavaScript executed that is making harm to your user. And DOM-based attack, cross-site scripting attack, is based on the fact that your framework like Angular or React during the runtime of your application is actually changing the DOM based on the instructions that the user let's say performed on this website. So the difference is that the place or the moment where this malicious code is injected and executed on your website. And the other dimension that says that this can be either reflected or stored cross-site scripting means that stored cross-site scripting attack is based on the fact that the malicious code is stored on your backend, like in the database, in the form of persisted comment, which contains of the content which contains some some malicious code that somebody then loads these comments, and this comment contains some JavaScript that can steal your cookies. And reflected cross-site scripting is not taking this code from some stored persistence layer, but maybe from the URL that is properly crafted, and the unaware user clicks the link, and your application is taking query parameters which may be constructed properly so that then the content is injected to the DOM and executes malicious or hostile code. So we will see examples of both attacks, but for now we are trying to see a high level description of this kind of attack. So as I said, DOM-based cross-site scripting is available, or maybe the case of DOM-based cross-site scripting is when you are using like frameworks like Angular and React, where the malicious code is injected during the life cycle of the application by your website front-end code itself, not by the server, but by the front end. How is this possible? In this example, we have some shop application that lists products, and it is possible to attach new product with some arbitrarily, let's say, typed in content. But if here we craft a product description that would contain an image with this code like on error, alert, I have your cookies, and we craft the source to contain unavailable image, then on error callback executes, and anybody who then opens this website that is going to fetch the products and render the list is going to have this code executed. The good part is that Angular has built-in mechanisms that prevent this kind of attack, these kinds of attacks. But if you need to render, HTML that is user-defined, you can fall into this trap. We will see this exact example in the labs section of this module. But now let's see here another slide that presents what is this attack about. So you see that the application executed API call to products endpoint, and there is a list of products that was received from the backend, and one of those products, number 2, contained the product description with this malicious code that ends up executing this on error callback alert, and I have your cookies. Just a question, or maybe a reminder, there is content security policy mechanism that can prevent this to happen. So we already know that we can protect ourselves from this kind of attacks with proper content security policy implementation. Reflected cross-site scripting, on the other hand, is happening when there is no malicious code on the persisted layer, or maybe, yes, persisted layer, I mean database or some store, and it's fetched from the backend, but it's actually taking the input from the user input, maybe from URL, like search term, and using this value to inject it to the DOM. In this case, let's see the example. We have search cats, and this value of cats is here displayed. But if I craft this search term in some way that it injects some malicious JavaScript and send this link to the unaware user, and the website is vulnerable of these kinds of attacks, this may end up actually executing this JavaScript code, and you see there's an alert saying I have your cookies and the session ID. And in this situation, then this script may send this cookie value to the hacker, to the hacker's server, so that he can read it and use it to impersonate your user. So this is really serious. And how is this possible? I already told you that when it comes to Angular and also React, Vue as well, we have built-in mechanisms to prevent these kinds of attacks. So sticking to Angular example, it is not possible to render HTML tags and JavaScript code in your DOM unless you call bypass security trust HTML, because by default every input is going to be going through sanitization, which means it's going to be removed of any malicious code. But if you want, or if you need to, display some HTML, some styles, or some SVGs, something that is actually an HTML template that you really want to render, you want to turn off this sanitization process, and this is called in Angular by the method bypass security trust HTML. There are different contexts of bypassing the security trust. In this case, we are presenting HTML contexts. So you see, we are using this product value to place it in the inner HTML, and now because of this fact, this website is vulnerable of injecting some dangerous code. So if you use bypass security trust HTML or any other bypass security trust method, you are responsible for, of sanitizing your content, because you just turned off the default sanitization process that Angular framework is doing for you. Yeah, and also, as I said, other frameworks like React, Svelte, or Vue can allows you to turn off the default sanitization process throughout the content of user comes through. In Angular you call bypass security trust. In React you say dangerously set inner HTML to allow custom templates to be rendered. In Svelte you have special methods, as also in Vue. So if you want to read more about these methods, there are links in the description of this lesson. So now, as we know what are the different types of cross-site scripting, let's see a real-life example of code that actually executes this kind of attacks. In this lesson, we are going to take a look at the example application that is vulnerable of cross-site scripting, but to be more precise, DOM-based cross-site scripting, which means our application, our Angular application, is going to be actually injecting the malicious code into the DOM because of the vulnerabilities that we actually introduce in our application. We'll see reflected and stored cross-site scripting in this example application. So let's start npm. By the way, these scripts are available for you. There's a link in the description. There's a link in the description to the repository where you can fetch this code and play it on your own. So let's run npm run XSS in our Angular ng build XSS watch. So now it's going to what is XSS, not CSS but XSS. So it's going to start our application here from projects. We have both. In the next lesson we will probably be diving into cross-site request forgery, but for now we are looking at cross-site scripting. Let's wait to compile. We have a list of products, and here you see that we have this sanitizer bypass security trust HTML, because we want actually in this application to render custom HTML, and by default Angular is going to strip those parts of HTML for the security reasons, because you know, by default every input in Angular is going through sanitization, and I will explain you in a second why we need to do this. So that we can achieve our result. So here, let's refresh our application, and we see we have a shop application that lists products, and the requirement that we have, we want to render custom HTML, like you see this CSS style applied, some SVG, because the products that we fetch from our backend through the request contain some, you know, descriptions that are composed of some custom HTML template. So if we want to do this and render it, we need to bypass the security trust, but this would end up with some serious problem that I'm going to present right now. So I'm getting this, let's take this code here, and suppose I'm adding some awesome product, but actually I'm attaching some image, and this image actually is pointing to some source which does not exist, and there's on error callback alert, I have your cookies, and then it will display the cookie. So you see that there was a post request to products, and the content with our custom template was sent. Now let's refresh this page, and the problem that you see is that now whoever opens our website, gets the products list, our application, the front-end application, in this case Angular, gets the list of products and renders this list, is going to also render our new awesome product that actually is having this malicious JavaScript that looks into the cookies. In this case, it just displays it in the form of alert, but it also could just steal this content of the cookie with maybe session ID or JSON Web Token and send to hackers or attackers server. So he now, as I said previously, whenever attacker manages to execute some arbitrary JavaScript code in the context of some user's browser, it's basically a game over, because now he can do whatever he wants. He can steal the session, he can look into the cookies, he can even look into the local storage and take the data and send it somewhere where he can read it. So yeah, we bypassed the security trust because we wanted to have this custom template rendered. So let's see what would happen if we turn off this bypassing of our sanitization here, rendering our products, let's say, in a secure way, because by default every input is going through sanitization in Angular. So I'm saving it and we are going back. Let's wait a second until it compiles till the end. Great. Going back to the application, let's do the hard reset. And now you see that a couple of things happened. First of all, there is no alert displayed, which means this malicious code was not executed, but our template, our custom template, was not properly rendered as we expected it to happen, because this HTML was stripped away of those elements that would make it HTML, valid HTML, to be properly, according to our requirements, rendered. Let's also take a look here. What happened here on the console log level. If we refresh, where we see some warning from Angular. It says sanitizing HTML stripped some content, right? So by default, if we didn't turn off sanitizer, we are safe, but couple of features that some features that we wanted are not working. So what we can do, let's get back to our unsafe sanitizing, which basically means now we are the ones responsible for making sure that the content we include in this part of the website, in this part of the application, is potentially going to inject some malicious code, and we are responsible of making sure that this is secure. So we could actually write some manual sanitizer that would strip away some parts of this content to make it secure. But another way, which is, I believe, a convenient way, is to just turn on content security policy. So before we do this, let's change our fake backend in this way that by default we will have some, you see here, some malicious code, like the product would have the description with this on error callback. So let's change it that now. Okay, so now our fake backend already contains this stored product description. That's why we right now are discussing stored cross-site scripting. And let's refresh the page, and you see that alert is displayed, and our template is rendered. And here, going back to our code, let's turn on content security policy, saying that script sourced can only be self. So it means that this inline script, inline handler, is not going to be executed. Let's save it. And yes, restart it. Again, hard to refresh. Now you can see our templates are rendered, but there is an error saying refuse to execute inline event handler because it violates the following content security policy directive. Script source can only be self. So Angular bundles were served from this origin. Like, let's see the network. You see Angular runtime, Angular main, .js files were served from this origin. So the policy directive saying script source self allows this to execute, but the inline script that was part of this product description was refused to be executed. So this was DOM-based stored cross-site scripting. Now let's take a look on DOM-based reflected cross-site scripting, which means that the malicious code is not stored on the backend, but reflected out of the application state. For example, from the query parameters. So let's see our app component again, and we can take the search term from the query parameters, and this is a rare case that we would like to bypass the security trust HTML in this query parameter, but just for the sake of this example, we are bypassing the sanitizer from we are bypassing the sanitization from the search term that we will take from the query, and let's see what happens. And of course, let's turn off our content security policy, which actually is our prevention from this kind of attack. So we are commenting out our content security policy setting. Let's do hard refresh and make sure that our content security policy is not enforced. Okay, one more thing. Let's take this malicious code from here and make this again a safe description. Let's go back. Let's refresh. And everything seems nice and great. Now I'm going to say that I want to search. Let's make first like search for, this is a fake search, like we are looking for a car, right? So you see our application is taking this URL parameter and rendering it here. This is this place where we took this query parameter and rendered it on the application DOM. And now if I send a link to some unaware user and say, and mask this with some href, and here this search term is going to contain this malicious HTML template. Let's make it this way, right? Is it correct? Image source style alert. Yes. And now I'm sending it via email or whatever else to some user that clicks the link or opens this URL address, and you see that something is not working properly. Let's see what we have here. Sanitizer. What we have here, probably it's not properly crafted. Search in error alert on error. Yeah, we need to close properly. We are closing the content and we are saving, and let's enter it. Yes. So you see now the JavaScript was executed, and this is the cross-site scripting variant, which is called reflected, because there's nothing persisted or stored on our backend, but only it reflected the state from the URL that application blindly trusted, because application wanted to display this search term on the DOM, but actually it contained the JavaScript, malicious JavaScript, that executed in the context of some user's browser that now is in danger because his session ID might have been stolen. So again, a way to prevent this to happen is to turn on content security policy. Let's go back to our server. Let's save it. And again, only the scripts that originated from self-origin may be executed in our application. So here, again, we have this script. Let's do hard refresh. And we see that now console error also says refuse to execute inline event handler because it violates the following content security policy. So here, this was the example of DOM-based reflected cross-site scripting, where the malicious code was not coming from the backend, as in the previous example where we were discussing the variant of cross-site scripting where we have stored code. That's why it's called stored cross-site scripting. In this case, we just tricked the application and managed to inject the malicious code into the URL, which blindly was placed in the DOM, which was dangerous in this case. And I hope that it makes it clear what different kinds of cross-site scripting we have.